All right, hello. My name is Jason Linville. This is a lecture on forensic science and the law. We'll explain what that is when we get into the lecture. It's being recorded for the class JS 110 Introduction to Forensic Sciences at UAB, or excuse me, Introduction to Forensic Science, I think. I don't even know the name of the course. At UAB, and this is being recorded in the fall of 2017, in December of 2017. So if you're accessing this archived lecture in future semesters, all the material still applies, but if I mention anything specific like quizzes, exams to the fall of 2017, you can ignore all that stuff. Although for almost all the classes that I've taught in this format, this lecture on forensic science and the law always comes last, and you'll notice it's chapters 1 and 2, and because of the material that we discuss in this class, it can be used as an introduction, but I prefer to bring it in at the end of the class. So it puts into, when we talk about admissibility of evidence, I can mention the different types of, evidence, and it makes a little bit more sense because we've talked about how there are more limitations on some as opposed to others. So I think it just fits better at the end of the class. So it's last lecture, typically done right before the exam, which in the fall of 2017, you had your last quiz yesterday. And then you have your exam coming up next Monday is when it's going to be available. So talk to me if that causes a conflict for you. And also for fall of 2017, part 1 of the exam is up. Part 2 for some reason is not visible yet, so I need to go back. I think I've uploaded it. I just haven't made it visible. I noticed that earlier today. So there will be 2 parts just like the first exam. All right, for this forensic science and the law lecture, it's going to be probably most similar to the psychology lecture that we just had, if you've watched that or haven't watched that yet, in that it jumps all over the place. There's so many different topics on forensic science and the law, and it's been spread out among so many chapters. Right now, most of this material is moved to the chapters 1 or 2, but it's not everything in chapters 1 or 2. So in other words, I just find a section that I think we should mention, and then I discuss it a little bit. All right, so it's sort of like, I don't know, best of legal aspects of forensic science. Okay, the first topic that we're going to, and I think I forgot to mention this right at the bat, and I'm sorry for those accessing the archive lecture, but for the new students, which there's a lot given the last lecture there, since everybody's on mute, if you do want to ask any questions, feel free to just throw them in the chat box, and I will see your questions. Okay, forensic science ethics. The reason why this is so important is that a lot of times forensic science is perceived as, objectivity. You put any scientist in the lab, they follow the protocol, they'll all get the same result and all testify the same in court. And while the following the protocol and getting the same result is true in some aspects, when it comes to testifying in court and interpreting the evidence, there's a lot of room for differences among forensic scientists. I mean, we just got done talking a little bit about forensic entomology and even with forensic pathology, estimating time of death. That's something where 2 different forensic scientists can come to 2 different conclusions, not just about, it was 2 days dead or 3 days dead, but about the range. Well, it's anywhere from 4 to 7. Versus somebody who says it could be 4 to 10 days. So the big debate becomes, well, could it be this body have been done 8 days? And you may get some different, it's not as though the evidence answers that question in an obvious way. And that can be true for a lot of different types of forensic science. As we've recently found, there was a video segment by John Oliver on the limitations of forensic science, and a couple of the, I think the Outline wrote a little segment, and there's a couple other news sites that, especially over the past 5 years or so, there's been a report that came out by the National Commission of Forensic Science that sort of reviewed forensic science cases, and it highlighted a lot of the limitations of forensic science. And this report that came out, I think the year was 2009, pops up every so often, and most recently it was due to the Jeff Sessions decision, to the Attorney General's decision to end the National Council on Forensic Science. which in the forensic science community also sort of, I don't know if upset is the right word, but it just seemed like they were doing good things, so why end it? And so this commission, highlighted a lot of the limitations of forensic science, and oftentimes that gets dug up and reported as forensic science is no good. Look at, these terrible mistakes it has made in the past. But to tie this back into ethics, when it comes to a forensic scientist testifying about hair or bite marks, which are two of the areas of forensic science that are often highlighted in that report, it's important to understand that, and as we learned in this class, you can get a match between a evidence sample and a known sample, but it's really about properly interpreting that match and letting the jury know, okay, are there any other explanations to this match? What is the rarity of this evidence? How many other people have the same type of hair that couldn't be distinguished between this hair found on the dead body? How many other people would produce the same size and shape of bite mark on this person? Because a lot of times with bite marks, they don't retain all of the details of the teeth. So it's up to the forensic scientist. This is a long way of saying it's up to the forensic scientist not just to go in there and tell the truth in terms of, not lying, like and the DNA matched my ex-wife. Nobody checked the report, but it's presenting the evidence, as that second bullet states there. It's presenting the evidence without distortion, including the relevant information, the statistics on the rarity of the evidence, and not allowing the jury to come to a different conclusion. If the defense or the prosecution, start to make a statement, so you're saying this hair matches this individual, you might want to make sure that the jury understands, okay, a match is not the same thing as saying it definitely came from the defendant. So, presenting this and communicating effectively with the jury who doesn't have the same level of knowledge in the field as a forensic scientist, that's difficult. And it's something that experience, both in your training and also experience on the stand, encountering some strange questions that attorneys may ask and determining how to best handle them, that's something that experience helps out a lot with. Okay. Now, in this area of forensic science ethics and the way the forensic scientist should testify, the book uses this term Sherlock Holmes witness, which I may use on a quiz or exam question. And a Sherlock Holmes witness sounds like it would be a good thing, because Sherlock Holmes not only solved a bunch of crimes in the books, but also fought people with his shirt off in the movies. I'm not sure exactly. I'm sure that was probably in the book somewhere. I didn't read a lot of the Sherlock Holmes books, so who knows. But Sherlock Holmes we definitely associate with being a good guy, like the world's greatest detective. Or is that Batman? It doesn't matter. Okay, good detective Sherlock Holmes. But here, the way the book describes it is a Sherlock Holmes witness is one that makes conclusions without considering other possible explanations. We could probably call this a CSI Miami witness in modern day. And I've talked about this before in the course, how in the show they're analyzing like a fingernail, and they're like, oh, this fingernail polish came from the CVS on Fifth Avenue, and they go there and their suspect is like hanging around in the parking lot or something. It's where the evidence analysis that they do in TV and the movies helps their investigation, okay? And it's sort of the self-fulfilling prophecy where they think, the boat glass came from this boat down on the dock, and they go and they find somebody cleaning up boat glass in front of the ship that their suspect's sister owns or something like that. But in forensic science, in the real world, a forensic scientist has to go into court and testify. And when you're testifying, it's not where you get this affirmation of a confession or, some obvious other follow-up piece of information that seems to reaffirm your conclusion base. So a Sherlock Holmes witness would go into court and say, the hair came from that man. I could tell because it had frosted tips, and only Guy Fieri has frosted tips. Okay, and then the defendant is sitting over. I forget, what does Guy Fieri say? Somebody throw that in the chat box. Guy Fieri's catchphrase. Yeah, Emerald is bam, but that's probably before all of yours time. anyhow. Okay, so the Flavor Town, that's right. Okay, now I'm reminded of memes and gifs with Guy Fieri. All right, so the Sherlock Holmes witness makes an impressive witness by saying you came from that man, okay, and doesn't consider any possible conclusions. But in reality, when you go into court, you have to say, well, it matches, but here are the other possible explanations. Or other people could also have that same type of frosted tip hairdo, okay? Maybe if a time machine is in play, then we have Lance Bass coming forward from the past to have, I don't know, you can play your own game of who has the most famous frosted tips at home. Okay, and hey, if any of you are sitting there touching your hairdo going, oh my god, maybe, hey, I'm sure it looks great on you. Okay, so identical, as let's conclude this section on forensic science ethics, that identical scientific results can be interpreted differently by different forensic scientists, definitely presented differently in court. So the forensic scientist wants to avoid being overly definitive or overly inconclusive. Now we're going to go over and give examples of both of these terms. So again, you can answer a true-false question on a quiz or exam. Now, the overly specific and why that is bad, that is, I think, a little bit more obvious than the overly inconclusive. So let's look at that one first. The gunshot was fired at a distance of 48.2 centimeters from the victim. Let's suppose I'm a forensic scientist. I get on the stand and make that statement. Well, from the small amount that we talked about, range of fire estimations, that statement 48.2, it almost implies that it wasn't 48.1 and it wasn't 48.3. It was 48.2, like I know exactly. But we know that when you're estimating the range of fire, you really can't give a specific measurement like that. You have to give a range. And normally in range of fire, it's either contact, near contact, intermediate distance, or long range. So by giving an exact number of that, you're doing a disservice to the jury and the court by being overly too specific when you can't be that specific. I mean, saying the bite mark definitely came from this person and no other is also sort of an example of this overly specific comment. Okay, now let's look at overly inconclusive. The gun appeared to be 2.2 meters from the wall. Okay, now at first this doesn't seem like there's anything ethically wrong with this statement, and it's not a lie or anything, but it's more bad practice for the forensic scientist, because here's the thing. The gun appeared to be 2.2 meters. The 2.2 meters in this case is not an estimation or a calculated conclusion. This is a measurement that the forensic scientist takes. So if you use the term appeared to be 2.2 meters, then it's sort of where not just the measurements, but also the conclusions, everything becomes very gray area, approximately this. And if you're being inconclusive when you don't need to be, then that can affect the jury, where they're sitting there thinking, well, this guy doesn't know anything. I mean, if the GCMS comes back and the retention time of a peak is 14.7, then you say it's 14.7. You don't say it's approximately 14.7. Okay, now if you're talking about where the retention peak for cocaine is, then that, depending on the instrumentation, is a range. So you can give a range or say approximately if you're describing where cocaine would normally fall. But if it's a number that's spit out by an instrument, if you match 15 minutia in a fingerprint, don't say, we match about 15 or so. No, specifically state. Okay, so hopefully you guys can start to see the difference between stating a measurement, which is specific, and then the conclusion, which can be a little bit more of a range. All right. Okay. Now we're moving on to a separate topic. That was forensic science ethics. We had the Sherlock Holmes witness, the overly conclusive, overly inconclusive statements. Now we're moving on to some information about forensic evidence, or really, evidence that's analyzed by a forensic scientist. It's important to remember this evidence is still circumstantial. I mean, we think forensic evidence, we think, it's going to give us a more definitive answer. Circumstantial evidence, that's like I was buying a candy bar in a gas station, in the sack of suds when the clerk got shot. But no, forensic evidence is still circumstantial because it just makes implications about the reconstruction of the case and guilt and innocence. Like that last bullet there, even finding a suspect's blood at the crime scene, it implies the suspect was at the crime scene. Right? It could be where somebody took the suspect's blood and planted it at the crime scene. So it's just a matter of, and this goes back to our testimony assignment, the forensic scientist just gives facts and information and helps draw conclusions for the jury, but it's really up to the jury to make that final decision. Okay, based on this information, did the blood come from the suspect? Well, the profiles match, and he said the frequency of the profile is 1 in 3 billion. Yeah, I think it did come from the suspect. Now, does that mean the suspect was from the crime scene? Yeah, I think the blood got to the crime scene because the suspect was there and bled all over the place. And then, does this mean that the suspect is guilty of the crime and lying about it? The jury sort of does that, but the forensic scientist just helps with the first part. So even evidence that's analyzed by a forensic science lab, it still would be classified as circumstantial evidence. Okay? All right, now even though this has the same title, which is probably lousy, this should probably be changed here because we're starting to talk about admissibility of evidence. Okay? And here it's important to realize, I mean, let's just think about this from a perspective, okay, what evidence makes it into court? Well, number one, when a crime is committed, somebody comes in here, opens up my bedroom door, I don't know why they would do that, and says, hey, are you Dr. Lynn? Yeah, I am, and then they murder me. Okay, you guys get to watch it on webcam, great. Hopefully somebody has screen capture ability. All right, and then the police come and they're investigating crime. During that murder, like the murderer has left a whole bunch of, they're picking up fibers on their socks, they're leaving fingerprints. If there's a struggle, they're leaving blood. My blood's probably transferred to their clothing. There's all this Locard exchange principle, transfer of evidence. Their car may have been caught on a security cam by one of the neighbors. There may be faint tire tracks. So there's a lot of physical evidence, but the problem is the only thing that can make it into court is the evidence collected by the investigator. So you actually have to find it and be able to collect it. Okay, and almost every crime, there's going to be evidence that's never found. A fingerprint that's never turned up, a footprint that's not analyzed or seen, digital information that could have been useful but is not known about. And even this evidence that's collected, if you collect a blood stain or a hair, there has to be evidence that can be tested and produces results. Maybe the drug sample you got there's not enough of it. Maybe the blood that you collected is a mixture and it's difficult to interpret. There's a lot of reasons why the evidence that is collected by the investigators might not produce that perfect conclusion. There's fibers on, it looks like the person who was murdered was hugging somebody wearing a sweater. You may look at those fibers and never find out where they came from. All right, so the evidence that's collected also has to be able to be tested and produce some result that's useful to the investigators. And then finally, this evidence has to be allowed into court, and this is where the admissibility of evidence comes in. It has to be allowed into court according to the rules of it. This is not just as far as the protocols were followed properly in the lab, but this is more a bigger picture of, okay, is DNA evidence allowed into court? Is blood spatter evidence allowed? Is bite marks allowed into court? Are polygraphs allowed into court? So these are questions that the court has to answer, and the reason why that's an interesting question is because it's up to the judge and the attorneys to decide what gets into court. And this was also another side of forensic sciences that was highlighted in that John Oliver video. I've started to cut clips from that, but they haven't made it into this version of the lecture. But the way that he states it is you have a prosecutor that is arguing for the admissibility of scientific evidence that the prosecutor doesn't understand. And on the other side is a defense attorney that doesn't understand the evidence, and they're presenting this to a judge that doesn't understand the analysis, and then finally it goes to the jury that doesn't understand the analysis. So it's up to the judges to determine the admissibility and the reliability of evidence. And yeah, they have some experts come in to help them make that decision, but for the most part, it is there. So there are some general rules that they follow when it comes to scientific evidence, which would be forensic evidence, whether that should be allowed into court. All right, now all of this stuff, the evidence has to be reliable. So that's sort of the big word that we're going to use. Okay, is this reliable? All right. Well, there's little mini steps that the judge can take to determine whether it's reliable and should be admissible. All right. The first example of a court case that a lot of state and then, well, the federal courts, but a lot of states sort of base their admissibility of evidence on this Frye test. So if, bite marks are presented to court and the defense attorney, the bite mark on the dead body matches the defendant, or so says the prosecution, and the defense is going to argue, hey, with the recent cases that have been overturned and we found that bite mark analysis is not reliable, I don't want this bite mark analysis to be accepted into court. Okay, and the prosecutor is saying, hey, this is very useful, don't worry, we're going to present it. And the expert that's presenting the bite mark is going to highlight the limitations. All right, and the defense comes back, we shouldn't even let it in. Yes, we should. No, we shouldn't. And then they start a fist fight. Okay, what does the judge do? Well, the judge looks at that evidence and asks these following questions. Number one, is the theory generally accepted in the scientific community? Okay, the theory for bite marks would be that, number one, if you bite somebody or something, the impression of your teeth are going to be transferred to the item. And it's also, the theory is that people's bite marks don't change over time and that they are specific to an individual. Okay. Now, notice, because we've gone over a lot of different types of forensic evidence, it doesn't have to be perfect. Your bite mark can change over time and have it still be admitted. And a bite mark doesn't have to be specific to an individual and it can still be admitted. But if the scientific community doesn't generally accept that for the most part your bite mark doesn't change, and for the most part people have different bite marks, then that would be one reason why the judge could throw that out. It's just the theory behind it. Okay, number two, is the scientific method used generally accepted in the scientific community? Okay, so let's go ahead and stay on bite marks. The methods would be maybe making a cast of the bite mark, comparing a photograph of the bite mark to dental records from the defendant. Whatever the method is as far as how the scientist does the comparison, that has to be generally accepted. Okay, let's go ahead and jump to DNA, which is maybe a more accepted. So we'll use bite marks bad, DNA good, just for the sake of an easy argument. For DNA, it would be the scientific method. Okay, can I take a blood stain and extract the DNA by adding a lysis buffer and putting it through a silica column and washing it off, and then amplify the DNA by putting these primers and Taq polymerase in a tube and putting it in a thermocycler, and then taking that product, putting it in formamide and separating it through a capillary and measuring the STRs. Okay, that method of actually doing it to get the result, is that generally accepted? Okay, so it's the theory as far as, can this work, or is the evidence we're looking at specific to an individual, doesn't change over time, and then the method involves the steps in the lab that are taken. Okay, number three, has the technique been applied correctly? Even if the method is accepted in the scientific community, if you have some bozo who doesn't know what they're doing running the samples, okay, then they may mess up the technique. Okay, the method is put Taq polymerase and DNA and primers in the tube. If you have an analyst whose technique is putting Taq polymerase in the tube, the DNA on the wall, and shoving the primers up their nose, then that's not applying proper technique. Okay. Although I am working, this is hush-hush, working on a way to amplify DNA by shoving the reaction up my nose. Okay, don't tell anybody that. It's difficult to change temperatures inside your nose, but that's really the challenge, and I think if I figure it out, it'll be big money. Okay, this slide I've messed up because I have the title on here twice. When I reformatted these slides, there are some errors that I'm catching. Okay, Daubert test in 1993. you'll notice with the Frye test, okay, it's a series of 3 questions. Theory, method, did you do it right? Okay, there's a lot of questions that aren't. How do you determine whether the theory is generally accepted? How do you determine if the method is good? How do you determine if the so what Daubert did, and this was a case with a pharmaceutical company, and I can't remember the specific forensic aspect that was brought into question, but Daubert still asks questions that the judge can ask about the method, but you're going to notice it's a little bit more specific. All right. Uh-oh. Okay, so we have an issue with the sound that occurred at 6:34 and 6:35 p.m. All right, everything looks good from my area. Okay. All right, can anybody, if you're not paying attention to the chat box, we're having a sound issue. Can anybody say whether they can still hear me right now? Okay. Yeah, I'm trying to think. I mean, I think my son's watching YouTube. Is that that screwed it off? All right, good. Thanks, Blake. It would. I mean, it's probably either on my end or on the go-to training if multiple people are having the same issue at the same time. So we'll see. It looks like it's gradually working itself out. All right. They put. Well, all right. Hey, we don't want to get into a net neutrality issue here, do we? All right. So let's go back to Daubert. All right. The Daubert issues are that and also for everybody who's listening, this is usually just a live issue. So in other words, if there's a couple slides that get screwed up on, just go back and watch the archive when it's up. And if you're studying and something's not clear, and it should be fine in the archived issue. It looks like a whole bunch of people are jumping out and coming back in. Okay, so with Daubert, a little bit more specific. Okay, has a scientific theory or technique been tested? So now here, notice it's not just asking whether it's generally accepted, but it's specifically asking whether somebody sat down and tested it. All right, has the scientific theory or technique been subjected to peer review and publication? So now it's clarifying how it's tested. You know, when Frye said it's generally accepted in the community or the method is generally accepted, here in Daubert, they're clarifying that means it's published in a scientific peer-reviewed journal and other scientists have had a chance to comment on it, accept it, refute it. So it's just being a little bit more specific about what this reliability is. Okay, what are the known or potential error rates of the theory or technique when applied? Okay, so again, you know, it's okay if there are some errors, you know, if not everybody has the same bite mark or if a person's bite mark can change over time, but it's just asking a little bit about whether you know what those error rates are. Like with DNA analysis, yeah, you can't assess human error rates necessarily, but you can assess and calculate the frequency of a profile in a given population. Does somebody else's? No, we're okay there. All right. Okay, as far as being able to hear each other, I have no idea how that's happening. That has to be a glitch because normally I have everybody muted when they jump in. So we'll see. Who knows? Something can be going on here. I'm having issues. All right, I see you guys. Yep. All right, I'm gonna just continue as though nothing went wrong, and we'll see what happens here. All right. So Daubert has it continues the question. So they have 5 questions as opposed to the 3 with Frye. Do standards and controls exist and are they maintained? Okay, standards and controls. This is directly relates to the third question of Frye. It's clarifying what it means by has the technique been applied correctly. Okay, to demonstrate a lab is doing the method correctly, they need to regularly run standards and controls and show that those standards and controls are producing the answers that are expected. Okay, and then finally, the theory or technique been generally accepted in the relevant scientific community, meaning you don't need acceptance from drug analysts if you are trying to get in a new DNA method into court. It has to be generally accepted in the DNA analyst community, if that makes sense. Okay, finally, so there's three here. I just want you guys, if I give you an example of one of these three, I want you to be able to identify it, or if I say which of the following is an example of the revised Rule 702, I want you to be able to identify it. The revised Rule 702, if you want to be lazy, it doesn't ask questions, it makes statements, okay? But we're going to look at these statements and see how they relate to Frye and Daubert. Okay, it's the same thing, just trying to clarify Frye a little bit better. Okay, so it says, yeah, this evidence should be led into court if the testimony is based on sufficient facts or data. Okay, that's sort of a general statement. The testimony is the product of reliable principles and methods. So again, it's principles, the theory, and also the methods. And then finally, the witness has applied the principles and methods reliably to the facts of the case. Okay, so again, it's sort of the theory, the method, and the application. But here, Frye is just statements, and it uses that term sufficient. What does it say? Sufficient facts or data. Okay, so now we're going to move on to a different topic, and this is more just sort of some cleanup stuff. We mentioned this at the beginning of the semester, but for students who are interested in pursuing forensic science, this is sort of common sense that their background checks are going to be similar to those required by law enforcement personnel. All right, so in other words, if you want to be a forensic scientist, you need to have the same, relatively clean record. And, it's important for you students to understand when you're in college, because when it comes to getting internships, it's not common, but it's not extremely unusual. If a student has a DUI or a couple DUIs, that can cause real problems with gaining employment or internships or getting a job in a forensic science lab. There's always these, weird rules about drug use come into play. Obviously, you don't want to be convicted of any felonies in your past, so if you got, when you were an undergraduate student, if you got caught stealing, I don't know, a statue off of the campus, I don't know, or stealing from work, or shoplifting, or grand theft auto. All of these crimes may prevent you from gaining employment in a forensic science laboratory. And so, like I say, you can get a parking ticket or two, but you don't want to have 50 unpaid parking tickets and go in and apply for a job. So just be aware that the background checks, they're treated the same. Okay, I think this is the last slide. This is Richard Nixon on the left and Elvis Presley on the right. I'm not going to start talking about whether Elvis was a spy or not. This slide ties into background checks, and it's mainly about Richard Nixon, who a quote from Miss Richard Nixon about polygraphs was, "The only thing I know about polygraphs is they scare the hell out of people." And the Frye case that we just discussed was actually about admitting polygraphs into court, and it was determined that they were not reliable and should not be admitted into court. Now, that doesn't prevent Maury Povich from making a show about it, but it is an issue in forensic science, not just forensic science, but it's an issue in law enforcement, in that polygraphs are oftentimes used as an interrogation tool during background checks. So what frustrates me as a forensic scientist is that polygraphs don't work, and it's a little frustrating that they're still using them in background checks. But if you do need to go through a background check, just be aware that you will take a polygraph. And it's not, some people say they hook you up and then ask you all kind of embarrassing questions. No, the polygraph is where you answer all the questions beforehand on a piece of paper, and then the polygraph examiner goes through those same questions with you, so you sort of know what the questions and what your answers are, and then they determine whether you are hiding something. Now, I have a personal beef with polygraphs, and I always end my class by telling these stories, not because I want to, but just because I think it may be helpful to some, where when I finished up my degree, my PhD degree, and was applying for jobs, I applied for 3 forensic science lab jobs, and I took 2 polygraphs for those, and I passed one of them, and I did not pass the other. And it turned out the other was the one that the job I decided on, contingent on the background check. and then it didn't go so well. And the question, it was drug use, and it was, I think, stealing from employers or something that they kept coming back to, and they determined I wasn't telling the truth when I was. And it always frustrates me because for the polygraph examiners, I'm not sure if the polygraph examiners know that, from a scientist perspective, if they understand the limitations of the polygraph, or if it's like the old hair and bite mark analysis where they're, testifying and sort of overstating the obvious. And, my problem with it is that even if it's used for employment, it's sort of an excuse where the person doing the questioning or the law enforcement agency can use it to discriminate. But anyhow, the reason I say this is I'm hoping if any of you are eventually in a position to decide whether to use the polygraph in pre-employment screening or in screening current employees, my vote is to decide against it. They used to use a lot in screening current employees. And if you look up the Wenho Lee case, who worked for Los Alamos, I think, research lab, he was accused of being a Chinese spy based on polygraph results, and it turned out there was nothing to it. So it's sort of where it almost is confirmation bias. If the investigators suspect something, then they can use the polygraph to reaffirm it, even if it's not true. So anyhow, we're going to go ahead and end the lecture here. I'm going to take another because I notice more people are in the room now. So if you just came in mid-lecture, hang out for a while to make sure I have your attendance. It also looks like we're having some extraordinarily horrible problems with sound tonight. I will blame AT&T for that. They put fiber in my neighborhood. Okay, I'm supposed to get 50 up and 50 down. And normally it looks pretty good, but who knows what's going on tonight with the audio. So anyhow, stick around. When I read your name, you can leave. And also, if you have any questions about anything, since it's the end of the semester, feel free to throw that into the chat box. What I'm going to do is I'm going to leave the recording running for a little bit longer, and then I'm going to stop the recording if you want to ask any other questions. All right, so where am I at here? End show. Okay. All right, so let me start at the top. Okay, Allison, you're free to go. Andrew, you're free to go. All right, Bethy, you're free to go. Blake, you're free to go. Destiny Houston and Destiny Schultz are both free to go. Erica Robinson is free to go. Jacob Wesley is free to go. Jordan Lacey is free to go. J.R. Chapman is free to go. Karen Thomas, let me write this down. All right, Karen, you're free to go. Maybe it's because we had too many people in the room tonight. Yeah, I'm changing. I'm not blaming AT&T. I'm blaming GoToTraining. Let's see here. Mackenzie Benish. All right, Mackenzie, you're free to go. Oh, wait. No, I had Mackenzie down before. Okay, Maddie's out of here. Okay, I have you down twice. Michael's free to go. Molly's free to go. Taylor's free to go. Let's see here. Tristan. All right, Tristan, you're free to go. All right, that's everything. All right, I'm going to stop recording if you guys want to ask